Hey everybody, today's lesson is on graphing functions. So now that we've talked about what a function is, when two numbers relate to each other, where the first given number gets matched with exactly one second number. So if we had something like y equals x plus 1, all right, where the x and the y each relate to each other. Depending on what I choose for x, I'm going to get a specific y that goes with it. Well, what's going to happen now is, what if we chose x to be 1? Okay, if x equaled 1, then we would do 1 plus 1 and we'd get y equals 2. And what we're going to do with this today is now we're going to write this x and a y as an ordered pair, but we're going to do that a few times. And then what we're going to do is we're going to take these points today and we're going to graph them. All right, so the function is y equals x plus 1, and it's asking us to graph this function. Well, what we're going to do today when we graph these things is we're going to get out our graph paper, all right, and on our graph paper, when we put our 3 points on the line here, what we're going to do is connecting those dots, and it's going to end up making a straight line. All right, a straight line is what we call a linear function, as we have here in the definition. A linear function is a function whose graph is a straight line, like this one. This one is called a function because when I graphed our line, we end up getting a perfectly straight line. All right, things that are not a function are things that are not straight. Not a function would be when I graph a line and I get something that looks like this. All right, where we got some curves or some bends to them. All right, things like that. Those are not going to be a function. Not a function. So what we're going to be doing today is we're going to be kind of piggybacking off of what we did when we learned about functions, making our XY tables. But then we're going to take it a step further. We're going to take these points and put them on a graph, and we're going to get one of these things where it's going to form a straight line today, which is called a linear function, a function whose graph is a straight line. All right, example 1 says graph the function y equals 2x plus 1. Okay, well, no different than what we did the other day. We're going to make our XY table. So I'm going to go ahead and do that here. Here's my x, my y. I'm going to make my t table. Now, the difference today is the other day they told us what x was. They said using the domain 0, 1, 2, 3. Well, today they're not going to tell us what x is. We get to pick whatever we want for x. All right, so you get to choose whatever your numbers that you want. The only thing that I'm going to say here is for our classroom, I'm going to say that you must choose 3 x's. Okay, always 3, at least 3. All right, so you can choose whatever x's you want. So my suggestion is make the numbers easy. All right, something like I'm going to choose 0 for x, I'm going to choose 1, and I'm going to choose 2. And that doesn't make any difference what numbers you choose. Just because I choose 0, 1, and 2 doesn't mean you have to. Someone else could have chose 0, 5, and 10. Or someone could choose negative numbers like -1, -2, -3. You get to pick whatever you want for x. But just like the other day now, one at a time, we're going to go ahead and take those numbers and put them in place of x and see what we get. So the problem is y equals 2x plus 1, and my first number is a 0. So I'm going to go ahead and plug 0 in for x and then solve this. So I get 2 times 0, which is 0, and 0 plus 1 gives me 1. Okay, so when I plug 0 in, I end up getting y equals 1 as my first answer. Okay, now the step today is I have to realize that this x and this y go together. So that's what I'm going to do is I'm simply going to write that as an x, y together as an ordered pair where the x coordinate's a 0, the y coordinate's a 1. Okay, I've got to do this again. Y equals 2x plus 1, but now I'm on to my next number here, this 1. So I plug the 1 here. This is 2 times 1 plus 1. Well, 2 times 1 is 2. 2 plus 1 gives me 3. Okay, so this ordered pair ends up giving me 1, 3. Okay, the 1 and the 3 go together. And then finally I've got to do this one last time, the 2x plus 1, but I have to use my final number, which is the 2. So this becomes 2 times 2 plus 1. Well, 2 times 2 is 4. 4 plus 1 is 5. So I get my final point, which is 2, 5. Okay, that's our whole point today. We want to be able to get these 3 numbers right here. Okay, 3 ordered pairs. Okay, so that's no different than what we did the other day. The new part now is now to take these ordered pairs and we're going to graph those on a line. So I'm going to move on to the next page here, and we're going to go ahead and graph those 3 things. So we get 0, 1, 1, 3, and 2, 5. I'm going to write those down again. 0, 1, 1, 3, and 2, 5. Those were our three ordered pairs. And what we're going to do now is we're going to go ahead, use our graph paper, and we're going to graph those three things. So the first one is 0, 1. So remember, the first number tells me either to go right or left. In this case, because it's a 0, it says go 0 right and left, and the second number tells me to go up 1. So I end up getting my point right at 0, 1. Okay, that was the first one, 0. Next one is 1, 3, which says go 1 to the right, and then up 1, 2, 3. So I'm going to end up right there. So that's where I'm going to put my point at 1, 3. Finally, the last one is 2, 5. So that's 2 to the right, up 3, 4, 5. All right, just a quick refresher there with our arrows. And I'm going to put my final point right there. Now what's going to end up happening is you get 3 dots that should end up being in a straight line. So what you need to do here then is take a piece of paper, like the edge of a piece of paper, or possibly a ruler, and you're going to try to connect these 3 points. But you absolutely have to try to make these as straight as. Now for the sake of me making my video, this might not be the straightest, but you should use a straight ruler here, and you're going to connect these points so that your line goes right through there. Okay, I do notice I made my line nice and long. I didn't make a real tiny one here and just stop it. Alright, I extended the line in both directions. I made it as long as my entire graph. Okay, I put arrows on the end because if our graph continued, it would keep going up in that direction, it would keep going down in that direction. But this, the picture of this line, is our final answer to the problem that we started with in example 1. Okay, let's do another one here. We'll do kind of this in parts. Graph the function y equals x minus 3. So the first thing that I want you guys to do, you're going to pause the video, you're going to make your xy table. Okay, choose your numbers for x, and then once you get your xy table done, once you start the video again, you can see what we did. Okay, so you should be choosing your numbers for x. Alright, I'm going to choose 0. I always choose 0, guys. 0 is an easy number to choose. Let's choose 3, because I know when I plug 3 in place of x, it's going to be 3 minus 3, which equals 0, so that makes it easy for me. And let's choose a number like, let's do 4, because again, I know 4 minus 3 is going to be easy. Okay, y equals x minus 3. One at a time I plug these in. The first time I get 0 when I plug the 0 in place of here. 0 minus 3. Well, 0 minus 3 gives me negative 3. Okay, then I'm going to go ahead and put the 3 in place of there. So this becomes y equals 3 minus 3. Well, 3 minus 3 is 0. Finally, my last one, y equals x minus 3, but this time I'm going to use 4 as my x, and 4 minus 3 gives me 1. So, next step, take these, group them together. So we get 0, negative 3. We get the next one, which is 3, 0, and then my fourth one, which is 4, 1. Okay? Now that you have your 3 ordered pairs, we need to graph these. So, we have 0, negative 3, we had 3, 0, and we had 4, 1. Okay, let's get our graph paper up here. Again, if you guys want to go ahead and pause the video, try to graph them on your own, see if you get the same straight line that I do. That would be great. Okay, you're back. First one, 0, negative 3 means 0 to the right and left, down 1, 2, 3. So 0, negative 3 gives me a point right there. So that one's done. 3, 0 means 1, 2, 3 to the right, up and down 0. So you get a point right there. That one's done. And my fourth one, or sorry, my third one, 4, 1. 4 to the right, 1, 2, 3, 4, and up 1. And again, guys, notice that when I put my 3 points on this, they really are kind of lining up so that they form a straight line. Alright, use a ruler, and we can go ahead and connect these dots. So I connect the dots nice and straight. I extend it as long as my graph in each direction, and I put arrows on the end. And there's my final answer. Notice that you should never end up getting something like this, guys. If you start putting your points on the graph, alright, and then you get something that looks like this, where you know to connect these dots, you're going to have to turn somehow. Well, obviously that's not going to be a linear function because it's not a straight line, because it has this bend right here. So make sure if you ever graph these and you get something that is not a straight line, you know you did something wrong. You can go back and try to fix it. Okay, last problem. It says a little rule of thumb here. A graph is a function if it passes the vertical line test. What I did was I put the picture of 3 different graphs on here, with the blue lines being the actual picture. We have to determine, just by looking at the picture, would this thing be a function or not? Well, a function has to pass the vertical line test, and what that means is, on my blue line, I can never have 2 points that are above and below each other. Okay, meaning that. So I'm going to draw a vertical line. I'm going to start with part B. What I'm going to do is, this is not part of the picture, but I am going to draw a straight vertical line. So an up and down line that goes through. This is what I call my vertical line test. Vertical line test. I draw a vertical line, and I'm going to see what happens. You see now, notice that the blue line touches my red line in 2 different places. That can't happen, all right? That is a big no. It can't happen. It's not supposed to happen. So if it does happen where my red line crosses 2 points on the actual blue line, we say that this line is not a function at all. So part B is not a function. So let's try to do that on part A, okay? If I draw a straight up and down line, notice it crosses my blue line just in one place. Well, that's okay. And I can draw as many of these red vertical lines as I want. You can see that it never ever crosses a blue line in more than one place on the same red line. So because of that, that's what we call as a function. It passes the vertical line test, because on any of the red lines I drew, there's only one place it crosses the blue line, as opposed to part B, where it crossed the red line twice. Okay, so there's 2 points above and below each other. You can try part C. It's going to be the same thing. It's only going to cross the blue line one time in any vertical line that I do. So this one is going to be called a function, and that is what we call our vertical line test. That is graphing functions, everybody. Good luck.